The application section consists of average, mixture, rate, and work-related problems. Among these, rate and work problems are very important for the GRE Quant section. Now, all the basic motion problems have three elements: rate, time, and distance. The relation between these are expressed by this equation. Rate into time is equal to distance. Let's see how this equation works in a math. Now, if a car is traveling at 30 miles per hour, how long does it take it to travel 75 miles? So here, the rate or velocity of the car is 30 miles per hour, and the distance that needs to be covered is 75 miles. So we have the rate and distance. We have to find the time. How long does it take? So we have to find the time. T will be distance divided by rate. So we have 75 divided by 30 is equal to 2.5 hours. Now, another type of problem is the work problem. You can use the same formula used in the motion problem, replacing the distance with work. So rate into time will be the amount of work, or you can write that the work rate is equal to given number of jobs or total work divided by the given amount of time, or the time. Let's look at an example. This is a sample work problem. Machine X, working alone at a constant rate, produces W widgets in 15 minutes. Machine Y, working alone at a constant rate, takes twice as much time to produce W widgets. How long, working simultaneously at their respective rates, would it take both machines working together to complete 4 W widgets? Let's narrow down the values that are given and the value that we have to find. Now we have the working rate of machine X. Since it produces W widgets in 15 minutes, it will produce W by 15 widgets in 1 minute. So the working rate of machine X is W by 15. Now, it takes twice as much time as X, machine Y. So it takes 30 minutes to produce W widgets, which means the working rate of machine Y will be W by 30, which is the double of 15. Now we have to find out the time it will take to produce 4 W widgets together. So we have the total number of work, 4W. The time is unknown and the rate is unknown. Now, since machine X and machine Y will be working together to produce 4W, so their individual rates will be added. So the new rate will be W15 plus W30, which is 3W by 30, reduced to its lowest terms, it becomes W by 10. So the new rate will be W by 10. Now if we look at this equation, we have the rate, which is W by 10, and we have the total amount of work, which is 4W. Now we can easily find out the time. Time will be work by rate. So work is 4W and the rate is W by 10. So we have 40 minutes. So if they're working together, they'll take 40 minutes to produce 4W widgets.